Look up. The sky above you seems ordinary, but it hides a mystery we often forget to ask. Why is the sky blue? And why, when the day ends, does that same sky catch fire in shades of orange and red? The sun hasn't changed. The Earth hasn't moved dramatically in the last few hours. So what is happening? Today we are going to follow sunlight on its journey through the air and discover how science paints the heavens. Part 1. What is light? To truly comprehend the intricacies of the sky, we must first delve into the essence of light itself. What appears to be ordinary white sunlight is, in fact, a complex amalgamation of numerous colors, specifically red, orange, yellow, green, blue, indigo, and violet. Together, these hues constitute the visible spectrum, which is the portion of the electromagnetic spectrum that is perceptible to the human eye. Each distinct color corresponds to light waves of varying wavelengths. Red light, with its longer wavelengths, resembles gentle rolling hills, while blue and violet light have significantly shorter undulating waves that appear more turbulent. This hidden spectrum is crucial because the manner in which light interacts with Earth's atmosphere is largely influenced by these varying wavelengths. Understanding this interaction is key to explaining phenomena such as the color of the sky, the formation of rainbows, and the scattering of light, all of which are vital to our interpretation of the natural world around us. Part 2. Why the sky is blue, a detailed explanation. As we gaze up at the sky, one of the most striking features is its vibrant blue color during the day. This phenomenon can be attributed to a fascinating interplay of sunlight and the Earth's atmosphere. To understand why the sky appears blue, we need to delve into the nature of light, the structure of our atmosphere, and the physics of light scattering. The nature of sunlight. Sunlight, or solar radiation, is composed of a spectrum of colors that can be seen when light passes through a prism. These colors range from red, with the longest wavelength, to violet, with the shortest. When sunlight enters the Earth's atmosphere, it doesn't just travel in a straight line, it interacts with the particles and gases that make up the air, the Earth's atmosphere. The Earth's atmosphere is primarily composed of nitrogen, approximately 78%, and oxygen, approximately 21%, along with trace amounts of other gases. This mixture of gases creates a medium where light can interact and scatter. When sunlight collides with these gas molecules, several interactions occur, but the key concept to focus on is the phenomenon known as Rayleigh scattering. Rayleigh scattering explained. Rayleigh scattering occurs when light travels through a medium and strikes small particles or molecules. The extent of this scattering depends on the wavelength of the light. Shorter wavelengths, blue and violet light, scatter much more effectively than longer wavelengths, red and orange light. The reason behind this lies in the size of the gas molecules in the atmosphere compared to the wavelengths of light. When shorter wavelengths of light strike molecules in the atmosphere, they collide and scatter in various directions. This scattered light then becomes what we see as the blue color of the sky. In contrast, longer wavelengths, which include red and orange, pass through the atmosphere with less interaction and scatter less, making them less visible in the overall presentation of the sky. Violet light and human perception. An interesting aspect of this scattering phenomenon is that violet light actually scatters even more than blue light due to its shorter wavelength. So, you might wonder, if violet scatters so effectively, why doesn't the sky exhibit a violet hue? There are a couple of explanations for this observation. Firstly, human eyesight is less sensitive to violet light compared to blue light. Our eyes contain photoreceptors called cones, which are responsible for color perception. The cones are more attuned to the blue end of the spectrum than the violet end, meaning we are less likely to perceive violet light in the sky. Secondly, the upper atmosphere absorbs some violet light. Ozone, a molecule that exists in the stratosphere, absorbs a significant amount of ultraviolet light and violet wavelengths, which contributes to the diminished visibility of violet in the sky's color palette. As a result, we predominantly experience a blue sky, where blue light is more pronounced due to the scattering effect combined with our visual perception. Conclusion: the illusion of color, In conclusion, when we observe a clear sky during the day, It is a vivid illustration of the complexities of light and atmospheric science. The vibrant blue color is not due to any kind of blue pigment in the atmosphere, but rather the result of Rayleigh scattering. The interplay of sunlight and the gas molecules in the atmosphere allows the shorter blue wavelengths to be dispersed in all directions, giving us the beautiful blue canopy overhead. Understanding why the sky is blue not only deepens our appreciation of the natural world, but also highlights the intricate relationships between light, matter, and perception. It's a captivating reminder of just how interconnected various scientific principles are in explaining the phenomena we often take for granted in our daily lives. Part 3. Variations of blue. Have you ever stopped to consider that the sky isn't always the same shade of blue? Our perception of the sky's color can shift dramatically based on a variety of factors, notably our elevation and the atmospheric conditions surrounding us. At sea level on a hazy day, the sky may appear pale and washed out, almost like a gentle watercolor backdrop. This subdued hue can be attributed to the multitude of particles and moisture that scatter sunlight. When you look up, you might notice that the sky lacks that vividness, becoming almost grayish or white as the colors mix together due to atmospheric interference. However, rise into the sky and look out an airplane window, and you will encounter an entirely different phenomenon. Here at cruising altitude, the sky often reveals itself in a dazzling spectrum of deep blue hues, sometimes appearing nearly indigo or navy. This stark contrast is primarily due to the significant reduction in air density and particulates as you ascend. When sunlight reaches higher altitudes, it encounters far fewer obstacles, allowing for purer, more saturated blue wavelengths to dominate our view. The science behind this is rooted in Rayleigh scattering, a phenomenon that explains how sunlight interacts with atmospheric particles. In clear, open air, shorter blue wavelengths scatter more easily, painting the sky with rich, vibrant tones. Conversely, in polluted or humid environments, more particles are present to scatter light, resulting in those lighter shades and a less defined color. Ultimately, the beauty of the sky lies in its ever-changing nature, influenced not just by the weather, but also by our position within the atmosphere. Each glance upward offers a new interpretation of blue, reminding us to appreciate the countless variations that emerge with changing conditions and perspectives. Part 4. Why sunsets turn red. And now we arrive at the enchanting transition of evening. Have you ever pondered why a bright blue sky transforms into a breathtaking, fiery sunset? The answer lies in the way sunlight interacts with our atmosphere. As the sun approaches the horizon, its light takes on a different journey. During this time, sunlight must pass through a much thicker slice of the Earth's atmosphere compared to when the sun is directly overhead. This increased thickness means that the light is not only traveling a longer distance, but also encountering more air molecules, dust, and other particles. The sunlight comprises a spectrum of colors, each with its own wavelength. The shorter wavelengths, which include blue and violet light, are more likely to be scattered in various directions by the particles in the atmosphere. This phenomenon is known as Rayleigh scattering. As these shorter waves scatter away, they become less visible to our eyes, gradually diminishing the blue dominance of the sky. What remains, however, are the longer wavelengths, those of orange, red, and yellow light. These colors are less affected by scattering, allowing them to remain more concentrated as they reach our eyes. This is why, as the sun dips lower in the sky during dusk, we are rewarded with the stunning display of warm colors illuminating the horizon. The oranges and reds seem to glow, painting the sky with hues that evoke a sense of wonder and tranquility. It's important to note that it's not that the sun itself is changing color. Rather, it is the filtering effect of the atmosphere that alters the appearance of its light. Each sunset is a unique spectacle, influenced by the atmosphere's composition, including humidity, pollution, and even dust particles, which can enhance or mute the brilliance of the colors we observe. So the next time you find yourself captivated by a sunset, take a moment to appreciate not just the beauty of the colors in the sky, but also the intricate dance of light and atmosphere that creates this daily masterpiece. The science behind this is rooted in Rayleigh scattering, a phenomenon that explains how sunlight interacts with atmospheric particles. In clear, open air, shorter blue wavelengths scatter more easily, painting the sky with rich, vibrant tones. Conversely, in polluted or humid environments, more particles are present to scatter light, resulting in those lighter shades and a less defined color. Ultimately, the beauty of the sky lies in its ever-changing nature, influenced not just by the weather but also by our position within the atmosphere. Each glance upward offers a new interpretation of blue, reminding us to appreciate the countless variations that emerge with changing conditions and perspectives. Part 5. Supercharged sunsets. Not all sunsets are equal. Some ignite the horizon with magnificent hues, while others gently fade into the night. The differences in sunset beauty stem from the particles that float in the atmosphere, everything from natural dust and smoke to man-made pollutants, each playing a vital role in how sunlight scatters as it travels through the sky. The phenomenon of scattering occurs when sunlight interacts with these particles. When the sun is low on the horizon, its rays must pass through a greater thickness of the Earth's atmosphere. This increased distance means more encounters with airborne particles that can scatter and refract the light. For example, during major volcanic eruptions, the ash released into the atmosphere can lead to extraordinarily vibrant sunsets. The eruption of Krakatoa in 1883 serves as a historical example. In the wake of this catastrophic event, observers around the world marveled at blood-red skies for months, a testament to how volcanic ash can dramatically alter the color palette of the sunset. In urban environments, pollution can similarly amplify the colors of the setting sun. The smog created from industrial activities and vehicle emissions adds countless small particles that scatter sunlight in intricate ways. This can create spectacular visual displays, with vivid oranges, deep reds, and purples, contrasting against the gray backdrop of pollution. However, these breathtaking scenes come at a cost, as they are indicators of harmful air quality that impacts human health and the environment. Adding another layer to this phenomenon, forest fires can release smoke that travels vast distances, affecting air quality and sunset aesthetics far from the source. Smoke particles can drift thousands of miles and tint sunsets in regions that are otherwise untouched by the flames. As a result, people far away can experience sunsets reflecting the devastation of wildfires occurring hundreds of miles away, showcasing the interconnectedness of our planet's ecology. Whether created by nature or human activity, these supercharged sunsets remind us of the delicate balance within our environment and the ways in which it can be both beautiful and haunting at the same time. Each sunset, an ephemeral masterpiece, tells a story of both creation and consequence. Part 6. Beyond Blue and Red. While Earth is renowned for its breathtaking skies, it's essential to recognize that other celestial bodies, like Mars, possess their own unique atmospheric wonders. The sunsets on Mars are particularly striking, and quite the contrast to what we experience here at home. As the sun dips below the horizon, the sky transforms into an enchanting blue hue. This fascinating phenomenon occurs because Mars's thin atmosphere is laden with fine dust particles. These particles are adept at scattering light. As the sun sets, the red wavelengths of light are scattered away, allowing the blues to prevail and paint the Martian sky in colors that seem almost surreal. These remarkable differences in atmospheric composition and behavior lead us to the skies of Earth, where the interplay of light, clouds, and weather results in a dazzling array of colors. The dynamic nature of our atmosphere plays a crucial role in shaping the visual experience of the sky. When water droplets cluster together in the atmosphere, they can scatter all wavelengths of light equally. This phenomenon often results in overcast conditions that render the sky a dull gray or a soft muted white. These gray skies may not inspire the awe that a blue sky does, but they bring a unique beauty and tranquility of their own, often associated with calm and contemplation. However, when conditions are just right, particularly during twilight, the sky can unveil its creative flair. This magical time, occurring just before sundown and after sunrise, allows the atmosphere to act as a canvas, blending physics with artistry. During twilight, the sun's light interacts with the Earth's atmosphere at an angle, softly diffusing into vibrant hues of purple, pink, and occasionally even deep greens. This spectacle occurs due to the longer path sunlight must travel through the atmosphere, which scatters shorter wavelengths more than longer ones, creating a symphony of colors that prompt many to stop and gaze in wonder. The interplay of light and air during these moments can evoke a range of emotions, stirring a profound appreciation for the natural world. Artists and photographers often seek to capture these fleeting moments, while scientists delve into the atmospheric phenomena that create such wonder. As we take a moment to appreciate the display before us, it's clear that both Earth and Mars, while different in their sky palettes, embody a rich tapestry of colors that fascinate and inspire, reminding us of the beauty in our ever-changing universe. Part 7. Human Meaning. For thousands of years, people have looked to the sky and tried to explain its colors. The vast expanse above us has always conveyed a sense of wonder, mystery, and inspiration. Ancient cultures, in their quest for understanding, often attributed the colors of the sky to divine influence. The deep blue dome of a clear sky was imagined as the celestial heavens, while the shifting hues of sunrise and sunset were perceived as the artistry of gods painting the horizon. These rich interpretations of luminosity were not mere observations, but reflections of human belief systems and cultural values. In various traditions, sunsets held profoundly significant meanings. In ancient Greece, for instance, the philosopher Aristotle poetically remarked how sunsets were moments in which the gods illuminated the end of the day, creating a palette that spoke to the transience of time and the fleeting nature of life. Many indigenous tribes viewed the colorful display as a gateway to the spirit world, a reminder to honor the cycles of nature and their profound interconnectedness with the universe. As the centuries unfolded, artists and poets continued to explore these themes, translating the ephemeral beauty of the sky into tangible art forms. Renowned painters like Claude Monet captured this phenomenon brilliantly, as seen in his much-lauded series of water lilies, which reflected not only the beauty of nature, but also the fleeting moments that can evoke deeper emotional responses. J.M.W. Turner, known for his dramatic renditions of the English sky, brought forth the sublime through his artwork, using swirling clouds and vibrant sunlight to evoke a sense of awe. His sunsets, filled with rich oranges and soft purples, stirred the hearts of viewers, encouraging them to reflect on their own experiences with nature's beauty. Poets, too, have woven the colors of the sky into their verses, often describing them as metaphors for passion, love, and life's transitory moments. The lines of poetry comparing the vivid sky to fire or silk resonate with readers, highlighting the duality of human experience, the beauty of life intertwined with the inevitability of change and loss. These connections between color and human emotion reveal the profound impact that the natural world has on our psyche, expressing what words alone sometimes cannot. While science provides us with the necessary mechanisms to understand the formation of these colors through the scattering of light, particulate matter in the atmosphere, and the effects of weather, it is our shared human experience that imbues these phenomena with meaning. The feelings we attach to these colors are not based solely on scientific principles. They stem from our capacity for imagination, reflection, and emotional depth. The sky remains a canvas of human experience, where art, culture, and emotional resonance converge to enrich our understanding of life itself. Final thoughts. Now that we've explored this magnificent phenomenon, you understand why the sky encompasses such a palette of colors. The azure blue we admire during the day arises from molecules in the atmosphere scattering shorter light waves, creating that captivating expanse overhead. As the sun descends, it embarks on a long journey through the atmosphere, and this extended passage filters its light, leaving us with the stunning reds and oranges of sunset, each hue a gentle reminder of the radiant warmth we often take for granted. Every sunrise and sunset serves as a beautiful metaphor. The allure of beauty does not solely lie within the objects we see. Rather, it resides in the intricate journey that light undertakes before finally gracing our eyes with its brilliance. So I pose this thought to you. If you could preserve just one type of sky to cherish forever, would it be the serene, clear blue of midday, the fiery gold and crimson of a sunset ablaze with color, or the profound velvety black of night sprinkled with shimmering stars? Which would you choose to hold close to your heart?